going to be a good session. As mentioned, we are shifting the focus back onto perovskites and some advanced materials in the PV space. And first, we're going to hear from Nano-C, from Paul Brookes, who is a director of device fabrication and testing there in Boston. So welcome on stage.
Okay, then. Thank you. First of all, I want to say thank you to TechBlick for giving me the opportunity to speak today. Hello, my name is Paul Brookes, and I am the Director of Device Fabrication and Testing here at Nano-C. And today, I would like to present some insights in the use of nanocarbon materials for solar applications. So firstly, I'd like to make a quick introduction to Nano-C. Nano-C is located around 20 miles southwest of Boston in Massachusetts in the USA. We are a chemical manufacturer of nanocarbon compounds and a leading developer of nanostructured carbon materials, which include fullerenes, single-wall carbon nanotubes, and their chemical derivatives. The company was founded by Professor Jack Howard out of MIT back in 2001. Nano-C's key mission is to play a role in enabling applications utilizing these nanostructured carbon materials and is committed to their responsible development and use. Technology developed by Professor Howard enabled large-scale manufacturing of targeted carbonaceous nanomaterials such as C60, C70, as well as larger fullerenes, and also single-wall carbon nanotubes. With our synthetic knowledge of chemical derivatization, we develop materials with selected electronic and physical properties targeting applications such as organic photovoltaics, organic photodetectors, perovskite PV, as well as other clean energy applications. We also develop formulations of single-wall carbon nanotubes in a range of solvents for numerous applications and deposition techniques. Nano-C has a range of one-pot silver nanowire single-wall carbon nanotube hybrid inks from transparent conductive electrodes, as well as CNT inks for use as opaque top electrodes within OPV and perovskite PV. Here I am showing how nanostructured nanocarbons can enable improved efficiency and sustainability in a number of application areas. Tandem PV can provide 30 to 50% more energy from the same area compared to traditional PV. It also has less environmental impact overall. Similarly, thin film PV technologies such as OPV can achieve reduction in buildings' thermal load by using solar windows. One of the biggest areas for thin film PV is obviously within building integration and building adapted PV, where silica just can't compete. These material sets are flexible, formable, lightweight, and there's a big advantage for using these thin film PV technologies such as perovskite and organic photovoltaics. To increase performance and stability of next-generation photovoltaic devices, Nano-C have developed a range of fullerene-based electronic transport layers and SAMs. Nano-C SAMs enhance device stability while increasing the ease of manufacture by eliminating the need for orthogonal solvents. Regarding ETLs, Nano-C has developed materials for both NIP and PIN architectures. Fullerene derivatives allow us to adjust LUMO levels in order to balance PV architectures. And we also have cross-linkable fullerene derivatives which stabilize stack integrity within the OPV and OPD devices. Here are some examples of structural fullerenes that have been evaluated within perovskite PVs. We have thermally, as already mentioned, we have thermally or UV irradiated cross-linkable systems, as well as passivation layers, self-assembled monolayers,